In this problem, we need to resolve the given rational fractions into partial fractions. Let us begin. So here, first thing first, all we have to do is check that the degree of the numerator must be always lesser than the degree of the denominator. Clearly, the highest power of x in the numerator is 1, and the highest power of x in each of the factors is 1, so that means they get multiplied to give us a power of 3. That means x cube is going to be the highest degree in the denominator, so that means we are okay to go. So here what we'll do, we'll first make an assumption. So we're going to suppose that our given rational fraction x divided by x plus 1 times x plus 2 multiplied to 2x plus 1. So let this be equals to the sum of three partial fractions. So the first partial fraction is a over x plus 1 plus the second partial fraction will be b over x plus 2, and the third partial fraction is going to be c over 2x plus 1. So these are the three partial fractions where a, b and c are constants. Our task will be to find out the value of a, b and c. So to do that, all we have to do is we are going to multiply throughout by the denominator of the rational fraction, which is x plus 1 times x plus 2 multiplied to 2x plus 1. So that means on the left hand side we're going to get simply x, and then on the right hand side we're going to get x plus 2 multiplied to 2x plus 1 whole multiplied to a, plus the second term or the second partial fraction will become x plus 1 multiplied to 2x plus 1 times b, plus we have x plus 1 multiplied to x plus 2 whole multiplied to c. Now what we'll do, in order to find out the a value of a, b and c, we will be using one trick here. So let's say, since we want to obtain the value of a first, we have to reject the value of b and c. Now what's the factor that's common to both b and c? So clearly it's x plus 1. So if we consider, let x plus 1 equals to 0, which means x is equals to negative 1. So if we take x to be equals to negative 1, then the second term and the third term disappears. That means they goes to 0, and we'll be only left with the first term, the term containing a. So that means our equation, so let's call it equation number 1. So that means our equation, so this is our equation, so this becomes negative 1 equals to, so in place of x we are replacing with a negative 1. So I have negative 1 plus 2 multiplied to 2 times negative 1, so that's negative 2 plus 1 multiplied to a, and the rest of the two terms are going to be 0. So with this we can now solve for a. So we're going to get negative 1 equals to, so negative 1 plus 2, so that's positive 1 multiplied to negative 2 plus 1, so that's negative 1 multiplied to a. So solving for a, we get the value positive 1. We're going to box it. Next, now we have obtained the value of a, when we are going to obtain the value of b. To obtain the value of b, what we have to do is we have to make the coefficient of a and c go to 0. So for this we see that the common factor common to both of them is this one, x plus 2. That's common to both a and c. So if we suppose that x plus 2 that's equals to 0, which means x is negative 2, then the coefficient of a and coefficient of c will go away. That means they will go to 0, and we'll be left with only coefficient of b, which will help us obtain the value of b. So this means that we are going to have to replace the value of x with negative 2. So our equation 1 now becomes negative 2, which is the value of x on the left hand side, equals to, so we don't have to worry about the first term because that's, let me write it down, negative 2 plus 2 multiplied to 2 times negative 2 is negative 4 plus 1 times a, plus the second term will be negative 2 plus 1 multiplied to 2 times negative 2 will be negative 4. So we have negative 4 plus 1 multiplied to b, plus the third term, which is negative 2 plus 1 multiplied to negative 2 plus 2 times c. So here we have this this term, the third term and the first term going to 0. We're now left with negative 2 equals to, so we have negative 2 plus 1, so that's negative 1 multiplied to negative 4 times 1, so that's negative 3 times b. So we have negative 2 equals to 3b, or b value is going to be equals to negative 2 over 3. Fine. So we have obtained the b value as well. And finally, we have to obtain the value of c. So to find out the value of c, we have to get rid of the first term and the second term. For this, we can see here that clearly 2x plus 1 is common to both of them. So we are going to consider, so let 2x plus 1 that is equals to 0. So that means we have to consider x to be equals to negative half. So on the left hand side, we had x. So x is negative half. The first term and the second term will go to 0. We don't have to worry about it. We only have x plus 1 times x plus 2 equal multiplied to c. That means we have negative half plus 1 multiplied to negative half plus 2 whole multiplied to c. We have negative half equals to the negative half plus 1. So that's positive half multiplied to negative half plus 2. So that's 3 over 2 times c. So here 2 and 2 gets cancelled. So c value will be equals to negative 2 over 3. So now we have the value of a, b and c. So we can replace this value back into our original assumption. And this is going to give us the required partial fraction. So let's do that. Thus, x divided by x plus 1 multiplied to x plus 2 multiplied to 2x plus 1. So that's going to be equals to a. So a value is 1. 1 divided by x plus 1 plus b. The b value is negative 2/3 of x plus 2. And then we have c, which is also negative 2/3 of 2x plus 1. So this is going to be the required 3 partial fractions for our given original rational fraction.